Well guys, this is the antiderivative from hell. This is the one you really need to know how to do because it does not fit the normal checklist of anti-differentiation techniques that you have learnt one by one. You don't have a derivative present with the integrand. You don't have linear substitution. It's not trigonometric, and partial fractions don't work. So what do we do now? Well, this is the one that I need to show you because it's the antiderivative rabbit that VCAR always pulls out of the hat because it's the most difficult. So let me show you, and please learn it. This is the one I call the split technique because we have to separate the above fraction into two separate terms before we even start anti-differentiating, and then it becomes straightforward. But you've got to be able to pick this one. This is the last one on the antiderivative checklist that you should be adding to your shopping list of is it this, is it that, etc. So there it is. Now what I'm going to do there is, as you can see, I've separated it into two separate terms. Now I deal with each of those separately, and then at the end I just combine the two separate answers as the antiderivative. Okay, let's take the first one. Now have a look at it. Have a look at it. How are we going to do that one? Have you picked it? Basically it's very simple. It is an inverse trig function, right? It's an inverse trig function is the antiderivative of this. Don't be distracted by the two, just put that outside there, and then you see an inverse sign sticking out a mile, don't you? Yes, if I put it that way, then you've got root 6 all squared minus x squared. You can see that it's inverse sine. So it's 2 times inverse sine of x over root 6 plus c. Yes? Now, what about this one? 4x over square root of 6 minus x squared with respect to x. Well, as you go through your shopping list of antiderivative techniques, you can see, guys, with a little bit of pea and thimble, we can organise that as the original function plus its derivative present in the same integrand, right? So if we let u equal 6 minus x squared, therefore du dx is minus 2x, and therefore du is minus 2x dx, and I can change this numerator so that it exactly fits that description by just a little bit of manipulation. So we've got, you see how I've manipulated it, minus 2 times minus 2x dx, which is exactly what I want for my du, over this little beastie, which becomes minus 2 times du over the square root of u, and it is very, very simple to anti-differentiate that now. Okay, so what it is, it's minus 2 times u to the minus half with respect to u, and it's just routine from there. You know how to do that. It's a polynomial antiderivative. So what's 1 more than a minus a half? It's plus a half, so it becomes the antiderivative of u to the minus half becomes 1 over plus a half u to the plus a half plus c, and don't forget the minus 2 out the front, and we get that, right? So therefore that becomes minus 4 times u to the plus half plus c, and we've done it, guys. We've cracked the code by separating this beast into two separate harmless little toothless tigers, which we've anti-differentiated separately. And here comes our answer for the second one after we've substituted back for u, and there is the answer coming. There. See? The split technique rocks, guys. So add that one to your shopping list of antiderivative techniques and you won't regret it. Okay, hope you got some value out of that one, and we'll see you soon.